Welcome to Teja Statistics. In this class, we are discussing about the testing of hypothesis, test for single mean. Okay, large sample test. After that, we are entering into the uh, unit number 2, that is testing of hypothesis and its calculations. Critical values also be completed in the previous session. Next, we have to see test for single mean. Okay, so test for single mean. Let x1, x2, x3 and so on xn be a sample of size n drawn from a normal population with the mean mu and variance sigma square. Then the sample mean x bar is distributed normally with the mean mu and variance sigma square divided by n. Let x follows normal distribution with the mean mu comma sigma square, and then x bar follows the mean mu and variance sigma square divided by n. You can see here, that is okay clearly. Let's take the null hypothesis for the test for single mean. There is no significant difference between the population mean and the sample mean. Mu is equals to mu naught. The alternative hypothesis, the mu is not equals to mu 1. There is a significant difference between the population mean and the sample mean. Okay. Level of significance, LOS. We consider at alpha level of significance usually at 1% or 5%. Test the statistic, that is test statistic we may use for testing the null hypothesis. The test statistic Z is given by x bar minus expected value of x bar divided by standard error of x bar. The standard error is said to be derived from the variance. Okay, so that is x bar minus mu or mu naught, we can write sigma divided by root n. So the sampling distribution of the test statistics depends upon the value of the sigma square. It is known or unknown. In case 1, sigma square is known, then in this case the test statistics follows normal distribution with mean 0 and variance 1. When sigma square is unknown, then it is replaced by its sample variance S square formula, 1 divided by n minus 1 summation I runs from 1 to n xi minus x bar whole square. Then test statistics can be changed into the student t distribution. Okay, generally follows the normal distribution. But if the population under study is not normal, then the sample size is very large, then the test statistics approximately follows normal distribution with mean 0 and variance sigma square. So conclusion, you have to make a conclusion for each and every test. Compare the calculated Z value, okay, with the table value if of Z alpha at alpha level of significance. If Z calculated value is greater than Z tabulated value, then we reject the H naught. If modulus of Z is less than or equals to Z alpha, that is table value, then we accept the null hypothesis. Note, the confidence limits of sample mean at alpha level of significance, the probability limits are expected value of x bar plus or minus Z alpha into standard error of x bar. So mu plus or minus Z alpha sigma divided by root n. If the population mean is unknown, then it is replaced by the x bar. At alpha level of significance we have the table value 1.96. At 5% of level of significance we have the 1.96. At 1% of level of significance we have the table value 2.58. okay, please remember these things. Okay, let's see test for differences of means. Let x1, x2 and so on xn be a random sample of size n1 and from a normal population with mean mu1 and variance sigma 1 square. Let y1, y2, y3 and so on yn be another sample of size n2 from another normal population with mean mu2 and variance sigma 2 square. Set null hypothesis that there is no significant difference between the two population means. H naught mu1 is equals to mu2 or mu1 minus mu2 is equals to 0. Alternative hypothesis that is mu1 not equals to mu2, mu1 is greater than mu2, mu1 is less than mu2. Level of significance, that is we consider alpha level of significance, that is usually 1 or 1% or 5%. The test statistic for large values of n, n1 and n2, the mean values are of x bar and y bar follows a normal distribution with mu1 comma mu2 and variances sigma 1 square divided by n1 and sigma 2 square divided by n2. Here x bar follows the mean and mu1 and y bar follows mu2. Just substitute that value in the z calculated. So x bar minus y bar of expected value of x bar minus y bar and standard error of x bar minus y bar. So if you substitute it, the z calculator will become like this: x bar minus y bar minus mu1 minus mu2 divided by sigma 1 square divided by n1 plus sigma 2 square divided by n2. Here the sigma 2 square is missing. Okay, 2 you have to write it under root of. Next, the sampling distribution of the test statistics depends upon sigma square and sigma 1 square and sigma 2 square. Both are known or unknown. Case 1, both are known, you can substitute directly. The case 1, sigma 1 square is equals to sigma 2 square is equals to sigma square, then the sigma will become a cancel, or we can see the common value here, and we got common here, the sigma square. Under root of sigma square will become sigma, so putting outside. Next, and sigma 1 square sigma 2 square are unknown, are known, then not equals to, then you have to substitute directly into the formula. Under h naught, the mu1 and mu2 will get cancelled. Okay, so that's why this z calculated test statistic become like this. Case 3, sigma 1 square sigma 2 square are unknown, then it can be calculated by using the formula n1 s1 square plus n2 s2 square divided by n1 plus n2 minus 2. Okay, what is s1 square, what is s2 square? Sample variances. Okay, like that you have to substitute the value. Case 4, sigma square sigma 1 square sigma 2 square are unknown and they are not equals to, then they are replaced by s1 square and s2 square. There are 4 cases in this calculation. Okay, the conclusion plays a very important role. Compare the calculated value of z with the tabulated value of z alpha at alpha level of significance. So that is, if z calculated value is greater than z tabulated, then we have to reject the h naught. If z calculated value is less than or equals to z tabulated, then we have to accept the h naught. Okay, next in next class we are going to discuss about the test for single proportion and two proportions also. Okay, next class we are going to discuss, and we have to see each and every topic should have some calculations part also, okay, the tests also. Thank you.